All right, so we're on 5-2, dividing polynomials. With this, we have to go back, way back, and remember some stuff. If you go back to the last chapter, quadratic formula works every time, right? But what was like quicker and easier if you could do it? Factor, right? So same thing here. Dividing with long division will work every time, but sometimes there's a quicker choice. So you have to know long division. It's not a choice, but the other option I'm going to teach you on the back is called synthetic division, and that one's really nice and really quick if you're allowed to use it. But there's rules to like when you're allowed to use it and when you're not, okay? So before we even do algebra with letters, let's take 9 divided by 5. Hello, that's not what I want. No, thank you. 9 divided by 5 without a calculator, because we won't have a calculator with letters, right? What do you do first? I know it's been a minute, but how many times does 5 go into 9 evenly? 1. What do you do with that 1? Not yet. Multiply by the 5. And then you subtract, right? And you get 4. So we won't have to worry about decimals, but that's what we would do here, right? You bring the 0 down, right? So you start all over again. You say, what's 40 divided by 5? Or how many times does 5 go into 40 evenly? That's the same thing, right? 8. You multiply again. You subtract again. Do you kind of remember that? Kind of, right? So that's what we're going to do today with long division, but it's with letters this time. The idea is the exact same. Don't let yourself get freaked out, okay? This first question, I'll come back and explain all this later, okay? This first question, it says simplify. This is a division problem. We could use long division if we want to, but this is called a monomial because it's one thing. If it had like a +1 there, it'd be called a binomial. It's not though, right? Do you get that that's a monomial in the denominator? Okay? So because of that, I can pull these apart and write them all separately. So I put these on separate pages so you could actually read. This is 17, okay? So I'm going to pull it apart. I'm going to write 9n cubed p cubed over 3n squared p squared minus 18n squared p squared over 3n squared p squared. Do you see what I'm doing? I'm splitting it up, okay? Plus 21n squared p cubed over 3n squared p squared. If it's a monomial in the denominator, the bottom, you can do what I just did, okay? This should look, if you like cover these two up with your hand, okay, this should look just like yesterday, right? It's just 3 of them. So you just do all 3, and it's all one big answer, all right? What's 9 divided by 3? 3 over 1 technically, right? So I'm just going to write the 3. N cubed divided by n squared. What do I do with my exponents? Subtract. What's 3 minus 2? 1. Would that go top or bottom? Top. So n to the 1. What about the p? P to the 1 on top again. Okay? That minus sign follows it. What is 18 divided by 3? 6. That's a 1 over a 1. That's a 1 over a 1. They canceled out. So 6 times 1 times 1 is still just the 6 with a negative sign in front, right? What's 21 divided by 3? 7. Cancel, or 1 over 1. And then 3 minus 2 is 1 on the top because it was bigger up top. That's it. Questions? Are you sure? Okay, we're done. Yeah, that's it. All right, number 10. We're going to do long division. If organization and not sloppiness, how do I say that? How do you say not sloppiness? If it's hard for you to write legibly, okay, then come and see me at some point and I'll give you like actual big graph paper, and it's easier to do long division on graph paper for some people. So if that's hard for you, then let me know later and I'll help you. So 10x squared plus 15x plus 20 divided by 5x plus 5. Just like what you did at the top of your notes. Okay? Same thing. We're going to take the first thing divided by the first thing. If that's hard for you to visualize, I just said 10x squared divided by 5x. What is that? 2x. Good. If division is hard for you, you could go backwards. You could say 5x times what gives me 10x squared. Either way, pick a method, okay? When we put something up here at the top of our notes, what did we do with it? We multiplied it, right? So this gets multiplied by everything in the front. So what do I get? 10x squared plus 10x. Is everybody okay with that?
Why'd you get oh, okay.
You good? Okay. What did we do next? We subtracted, but watch me if you can when you get a second. When you're subtracting more than one thing, it's like that. I don't think it's ever a good idea to leave it this way. I always distribute the negative. So watch. Add, opposite, opposite. Okay? If you don't do that, people almost always mess this part up. I always add the opposite. Do you need to see me do that again, or are you okay? You good? All right. What's 10x squared plus negative 10x squared? 0. If that doesn't happen, you messed up. That will happen every time. Okay? What's 15 plus negative 10x? 5x, and you bring down the plus 20. Just like what we did at the top. Is that okay? You start all over again. You say, what's 5x divided by 5x? 1. Right? Anything up top, what do you do with it? Multiply by what's in front. So I get 5x plus 5. What do you do with that? Subtract. Be super careful. You're subtracting the entire thing. So I'm going to add, opposite, opposite. I feel like that goes better for most people. Okay? What do I get here? 0. If I don't, I messed up. What's 20 plus negative 5? 15. Back in elementary school, you would have written R15. We're not in elementary school. So it's 15 over what you divided by.
What's that one mean?
Back in elementary school, it meant remainder. You know? Eventually, you learned other things, but that's probably what you remember today. So 15 is our remainder, and it's out of what we divided by, the 5x plus 5. That's long division. You should feel like we're close, but we're not done. Why are we not done? Wouldn't that reduce? Right? What goes in all three of those evenly? 5. So we get 2x plus 1 plus 3 over x plus 1. You guys see that? Now we're done. That's full credit answer. That one's like the quadratic formula. It works every time, but if I don't have to, I kind of don't want to. Does that make sense? Okay? The idea is not hard, but it's really easy to mess it up, just like the quadratic formula. The idea is not hard, but it's really easy. If you get one negative sign wrong, the whole thing's wrong, right? All right, so go to the back side. This says synthetic division, right? There's like a checklist you have to follow before you can even do synthetic division. So here's one thing you have to know. This has to be in descending order. Well, that's true forever, really. Descending order, right? No holes or gaps. What I mean by that is if this was gone, that would be a hole or a gap, and I'd have to put a 0 in. We'll have one like that in a second if that doesn't make sense. This has to be a 1, and this has to be a 1. And this has to be a binomial. I know that seems like a lot, but half of that's a no-brainer. Descending order, nothing missing. Binomial, which means 2, and it has to be 1 letter to the 1. As long as that happens, you can do what I'm going to do. This is called synthetic division. You could still do long division if you want, by the way, but I don't do it unless I have to. Does that make sense? Okay. If I were you, I would just watch me do it the first time. That way you don't miss anything. And then I'll erase it, and I'll do it again with you as you write it down. It's up to you, but I think it's nice to know that I'm going to give you that time. So if you want to just watch, I probably would. So once we've gone through our checklist, everything is fine, right? You set this equal to 0 and solve. So what would that be equal to? -3. -3 goes in the box. Okay? All the coefficients go behind it. 1, 3, -7, -21. Okay? All you do is you bring down this first number. You don't do anything to it at all. You just bring it down. Anything under the line gets multiplied by whatever's in the box. So what's 1 times -3? -3. Anything in here gets added together. What's 3 plus -3? 0. Under the line times the box. What's 0 times -3? Add -7, multiply by the box. 21, add 0. I will do that again, okay? And then I'll show you how to write the answer. So this time you can do it with me, okay? I know the first time you learn something, you kind of wonder, why did we learn this? But once you're good at it, this takes like 10 seconds maybe, and long division can take a while, okay? So, descending order, no holes, binomial, 1m to the 1, we're good. You set this equal to 0 and solve. What goes in the box? -3. All the coefficients go behind it. 1, 3, -7, -21. Technically, -21 is a constant, but you know what I mean. Okay? You bring the first number down. Whatever it is, you just bring it down. Anything under the line gets multiplied by the box. What's 1 times -3? -3. Anything in here gets added together. What's 3 plus -3? 0. Multiply by the box. 0 times -3? 0. Add. -7, multiply by the box. 21, add 0. Now that doesn't look like an answer, right? So here's how you actually write your answer. This was m to the third. You drop that down by 1 degree. So this is m to the second. This is m to the 1. This is m to the 0, which really means constant, and that's my remainder. So my answer is m squared minus 7. Ask me a question. You sure? You probably just need to see some more. Anybody still need this one? Okay, next one. Let's do our checklist. It's in descending order. There's gaps here. Do you understand what I mean by that? It jumped from y to the 5 to y to the 2. That can't happen. Okay? So, y to the 5 plus 0y to the 4 plus 0y to the 3 minus 3y squared plus 0y to the 1, constant, everything else. Take your time and look at what I wrote. When you do it this way, you cannot have holes or gaps. You have to fill them in with 0. Do you guys see that now we have 5, 4, 3, 2, 1, none? Is that okay? Is this a binomial? Yes. Is it 1y to the 1? Yes. What goes in the box? 2. Okay. What goes behind it? 1, 0, 0, -3, 0, -20. Is that okay? What do I do next? Drop the 1. That's not always a 1, by the way. Okay? Just drop whatever it is. Yeah?
Are you always supposed to have that extra line right there, like at the last number?
That extra line before the last number is to help you remember that that's a remainder if there's a number in the box. You don't have to put that line there, but I think it just kind of helps us distinguish that it's a remainder. Okay? So you just drop the 1. Anything underneath the line gets multiplied by the box. So 1 times 2 is 2. What do I do with those? Add. So what's 0 plus 2? 2 times the box. 4, add, times the box, add, times the box, add, times the box, add. It's not always 0, obviously. We'll get there, but did I lose anybody? Okay. We started with y to the 5, so what is this going to start with? Y to the 4, right? So it's 1y to the 4 plus 2y to the 3 plus 4y to the 2 plus 5y plus 10. Is that okay? That's it. It's your answer. Anybody have a question? Are you sure? We good? Okay. This one, there's a couple of problems with it, right? Do we have 3, 2, 1, no gaps, right? Is this a binomial? Yes. Is it 1x to the 1? No. So here's where you have two choices, okay? You could do long division if you want to. It's worth your time to try synthetic division with this one because it is quicker, I think. So we can make this a 1. How do I make it a 1? Divide by 4. But if I divide by 4, I have to divide everything by 4. It's actually not that hard. It works out pretty nicely. If you know you're going to mess that up, okay, you could put just an over 4 under every single piece. Do you get what I'm saying? Some people are going to screw that up, so don't put over 4 on everything, all right? So this is going to be x cubed plus 5 over 4x squared minus 3 over 4x minus 1 over 4 divided by x plus 1 over 4. I know that doesn't look pretty. You're going to be fine. Hallie literally is going, you're going to be fine. It's going to be fine. Promise. Does this look okay now? Do not be intimidated by fractions. You're not allowed to do that anymore. What goes in the box? Negative 1/4. What goes behind the box? 1, 5 over 4, negative 3 over 4, negative 1 over 4. Is that okay? Drop the 1 or whatever. Drop the whatever, okay? What do I do with that? Multiply by the box. What do I get? Negative 1/4. What do I do? Add. This is always going to be pretty. Well, not always. That's a lie. Most of the time it's pretty. 5 over 4 plus negative 1 over 4 is 4 over 4, which is 1. You didn't even need a calculator. Multiply that by the box, and you get negative 1 over 4. What's negative 3 over 4 plus negative 1 over 4? Negative 4 over 4, which is negative 1. Multiply by the box. Positive 1 over 4. Add 0. Again, it's not always 0. I always start you off a little bit easy, though. Okay, so we started with x to the 3. So this is x to the 2 plus x to the 1 constant. Is that okay? The reason we drop it by a degree, if I had done this long division-wise, 4x cubed divided by 4x is going to be something x to the 2. Do you see what I'm saying? It's always going to drop by a degree. That's why the rule exists. Okay? Are you ready? We're not actually going to do this one because I want to make sure we have enough time. This one, I want to make sure you understand. You don't have a constant and you need one. Okay? So 3, 2, 1, none. You would have to put a plus 0 there. And then divide everything by 2 and then do the problem. Do you see what I'm saying? Okay? If you don't put that plus 0 in, that's a gap, that's a hole. It wouldn't be right. So you have to have everything accounted for, including the constant. Do you get that? Okay. So we're not actually going to do that one. We're going to do this one instead. So write this one down. You should have space on the one we skipped. You could just kind of replace it. I did it next to it, but whatever works for you. That says 2x to the 4 plus 3x to the third, 3x cubed, minus 2x squared, minus 3x minus 6 times 2x plus 3 to the negative 1. Make sure you write it correctly. You guys okay? How is this one different? It's not division. Do you see that? Everything else had a division sign. Maybe don't write this down right now, just watch me. You'll have to do this once to understand what we're going to do, and then after that you can just memorize it. It's pretty easy to memorize. If this is to the negative 1 power, can't I make it to the positive 1 power? Do you understand what I just did? Okay. So that is 2x to the 4 plus 3x cubed minus 2x squared minus 3x minus 6 over 1 times 1 over 2x plus 3. Do you understand that's what we have? When you multiply fractions, you multiply the tops together all the way, and you multiply the bottoms together. So I have 2x to the 4 plus 3x to the 3, pretend that said 3, minus 2x squared minus 3x minus 6 over 2x plus 3. Doesn't that literally say this divided by this? So whenever you have it to the negative 1 power like that, that's what they want you to do every time. You don't ever have to show me that math again. I just wanted to explain to you why that really is division. Did you follow what I did? Okay, like I said, if you want to write it down, you're welcome to do that, but you don't have to, okay? I just want you to understand that when it looks like that, scribble it out, and it's really divided by. Are we okay? So now let's actually do the problem, okay? So I'm going to erase that because I don't really have room. If you really wanted to write it down, you can let me know later, and I'll let you copy it later. So I'm going to, oh, no. Dang it. I should have just reset the page. I'll write it again. It's fine. Okay. What did it say? 2x to the 4 plus 3x to the third
minus 2x to the second minus 3x minus 6
divided by
2x plus 3.
Thanks. So that's what we really have now. Do you guys get that? This is like the hardest question I would ever ask you. It was to the negative 1 power. Why else is this hard? Because it's not a 1, right? So we have to divide everything by 2 because of that guy. Does that make sense? So you write what you get. We get x to the 4th plus 3 halves x cubed minus x squared minus 3 halves x minus 3 divided by x plus 3 halves. Ask me a question if I lost you. Everybody okay? What goes in the box? Negative 3 over 2. That goes 4, 3, 2, 1 constant. So I don't need any zeros, right? What goes behind it? 1, 3 over 2, negative 1, negative 3 over 2, negative 3. Very good. Everybody with me? What do? Drop the first number, whatever it is. It's not always a 1, but today in my notes it is, okay? What do you do with that? Multiply by the box. So what do I get? Negative 3 over 2. Add 0, multiply, add, multiply, add, multiply, add. We had a remainder, right? Did I lose anybody? Okay. So we write, this is x to the 4, right? So this is x to the 3rd, 0x squared, so I'm not going to write it, minus 1x, constant, minus 3 over what I divided by. I divided by x plus 3 over 2. I didn't divide by that. Remember, I changed it? Okay. That should make you feel weird. Why? Fraction in a fraction. That's weird. Okay? So we have to focus on that. How do I make it not a fraction anymore? Right here. Multiply by 2. What do I do to the bottom? I have to do to the top. Do you understand that? Okay. So I still have x cubed minus x. The reason I'm allowed to do this is because multiplying by 1 doesn't really change the problem. 2 over 2 is 1, right? So I get 6 over distributive property, okay, 2x plus 3. 9 times out of 10, it's going to be what you started with. That's not a rule. I don't want you to think that's a rule. But a lot of the time, it'll end up being what you started with. So this is your final full credit answer. Questions?